Hey, hello. Welcome back to channel. In this video, we're going to see about cooling and heating effect of atoms and molecules. So we know that matter is made up of atoms, and when these atoms are combining together, it forms molecules. So now let us consider an example, and let us try to understand if you heat a substance, what happens to the atoms or molecules present in that substance. So here I have got the three states of matter: solid, liquid and gas, and in particular let us consider these particles as H2O molecules. Okay, so H2O, it's nothing but the molecular formula of water. So when it is in solid state, you will be calling it as ice, and when it is in liquid state, you will be calling it as just water, and in gaseous state, you will be calling it as water vapor. So what I'm going to do now is I'm going to add energy to the ice. Okay, so adding energy is nothing but I'm going to heat this ice. So when I heat this ice, what happens? Already the molecules present in the ice will be vibrating a little. There will be a little vibration present in it. Okay, so when I heat this, it gains more energy, and at one particular point it is getting converted to liquid. This process of conversion from solid state to liquid state, we are calling it as melting. Okay, so this process we are calling it as melting, and at a particular temperature this conversion will take place. At particular temperature, the solid will be converting to liquid. That point you are calling it as melting point. Okay, so I have got water now. Again, what I'm going to do, in the liquid state you can see the vibration is little more and the energy is also more. Okay, so here the energy has increased. Okay, now again I'm going to heat this. So when I heat this, what happens? It is getting converted to the next state, that is gaseous state. So from liquid to gas, you can call it as vaporization. Okay, so in the gaseous state, as you can see, it has attained its highest energy. Okay, so the energy is highest in case of gaseous state, and the molecules are very free and it is moving very randomly, and the vibration is also more. Okay, so now as you can see this transformation, there is no change in the chemical composition of the substance, only the physical state is getting changed. Okay, the state of the matter has changed: solid to liquid, liquid to gas. That's it. In all the three cases it is H2O only. Okay, so now when I'm adding energy, what is happening? The first one is melting and the second one is vaporization. Now what I'm going to do, I'm going to remove the energy. So how I'm going to remove the energy? I'm just going to cool down it. Okay, so if I cool down, what happens? Let us see. So if I cool this gas, if I cool the water vapor, it is getting converted to water again. What is this process called as? It is condensation. So what will happen here? The water vapor will release the energy outside. Okay, it will be releasing the energy outside and it is getting converted to water. So the energy is getting reduced. Okay, so again I'm going to cool down this water. So if I cool down this water, what happens? It get freezed. So this is called as freezing. Okay, and at one particular temperature it will be getting freezed. That point you will be calling it as freezing point. So what is happening in this process? Also the energy is lost. Okay, the energy is lost in case of from gaseous to liquid, and as well as from liquid to solid. Okay, it's a kind of reverse process what we have done, okay, by cooling it. So all these are happening in case of heating and cooling a substance. The first one was melting and then vaporization, and from gaseous state to liquid state it is condensation, and from water to ice it is again freezing. Okay, now let us try to understand the different process involved here. Okay, okay, so fine. Now what is happening? From solid to liquid, there is gain of energy, and from liquid to gas is again gain of energy. Okay, so when there is a transformation from one state to another state by gaining the energy, okay, by gaining the energy, those kind of process are called as endothermic process. Okay, those processes are called as endothermic process. Endo is nothing but inside. Okay, thermic means heat. Okay, so it is absorbing the heat, or it is taking the heat inside and it is transforming to another state. So which are the endothermic process here? Melting and vaporization. Okay, and then the second one here, what is happening here? Loss of energy is happening. The name itself suggests removing energy, so loss of energy. When you're removing the energy, what is happening? The energy is going outside. As I told before some time, from gas, when it is converting to liquid, the energy already present in the gaseous molecule will be released outside. Okay, all the energy will be released outside and then it will be converted to liquid, and the same thing happens. This energy which is in which is present in the liquid state, that energy will be released outside and again it is getting converted to solid state. Okay, so here what is happening? There is a release of energy. So when there is a release of energy and when it is converting from one state to another state, that process you are calling it as exothermic process. Okay, exothermic process. So exo is nothing but exit or outside. Thermic means heat again. So what is happening? The heat is going outside. In case of endothermic, the heat is coming inside. Okay, so these are the two things which you can learn by understanding this melting, vaporization, condensation, and freezing. The heating and cooling effect will give you the knowledge of endothermic and exothermic also. Okay, so in case of exothermic, what are the examples? It is condensation and freezing. Okay, so I'll just read out the summary of whatever we have discussed. It is melting, vaporization, condensation, freezing, endo and exo. So this melting and vaporization will come under endothermic process, and condensation and freezing will come under exothermic process. And as I told, endo means in, exo means out, and thermic means heat, right? I hope you're clear. Okay, so thank you all. Have a great day and happy learning.